Good. All right, consider the recurrence relation shown below. The value of A3 in the sequence generated by this recurrence relation is given by, so if you remember in your calculator, you can type in 3, press enter, and it comes up over here. And then what you're going to do, so they're saying the first term is 3, so then you've got to times that by 2, so you can, on your calculator, you can just write times 2 plus, plus 4. So, and it will give you that it's 10, because 2 times 3 is 6, plus 4 is 10. So this was A0, so this is A1. So A2 would be 10 times 2 plus 4, which is 24. And they want A3, which you would have gone 24, 2 times 24 plus 4. So there's how we can get that answer is there. So they're sort of testing you, because you can quickly do it on the calculator to get A3. So they're testing that you know what's actually happening there. All right, so in this next one, Jeff purchased a computer for $4,500. It will depreciate using flat rate at 10% off the purchase price per annum. So it's really important that you use you highlight what you're looking at, because they're gonna always tell you. So if you've got like flat rate and they want the recurrence relation, so you actually can use the table, that summary table I've given you. So I'm just going to quickly go get that. All right, so I've got that, the flat rate section of our summary table, and they want the recurrence relation part, which is always this column on the table. All right, so here they're showing me, if you look just there, is how to write the recurrence relation. So you start with VO, and they've all got 4,500. And the next bit we need is the VN plus 1 equals VN, and then minus, now we have the D is what you have to calculate here. So, and if you use that formula there, we can work out that the D part is equal to the rate, which is 10%, and it's per annum. So 10% over 100 times VO, which is 4,500. So if you do that, it ends up being 450. So you can see that when you write the recurrence, it should be VN minus 450. So that is how we get A. All right, so this is going to be a quick way of how to use the table and things. That's why the table's easy. If you underline what you've got and then go find that section on the table. So I've already sort of found it for this question. So if we look at question 3, a machine is purchased for 30,000. It produces 24,000 items each year. The value of the machine is depreciating using unit cost method. So this is where you're going to go find of depreciation. So I've gone and found that up on my table, and that's what I'm going to look at. And so after 3 years, the value of the machine is this. A rule for the machine for N units. So this column here in the middle on your table is always the nth term formula, or how to find the nth term rule. So you can see it there. I have to write VN, so VN minus equals, VO, which is what you purchased it for, which is 30,000, minus N times, now I need to find out what this D is. So there I've got to work out D. Now D is the amount depreciated per period divided by the number of uses. So I'm going to go calculate D. So the amount depreciated in the period. So after 3 years, it's gone down by, so if you look here, it started at 30,000 and it's now at 18. So if I minus that 18,480, that will tell me how much it's dropped by. And then it says divided by the number of users. So it's users 24,000, but for every year. So there's been 3 years. So I'll go do that on the here. So we worked out that was 0.16. So it depreciates for every use 16 cents. So then if you write out the VN formula, it'll be 30,000 minus, I'm going to write it, and then we normally say N times the use. So here we've got the answer is E. All right, so you can see that the formula sheet is going to make your life a lot easier. All right, so in this question 4, a truck was purchased for 134,000 using the reducing balance method. So they've told me the reducing balance method, so I've gone and found that part I'm looking at that part on my formula sheet, and the value of the truck is depreciated by 8.5% each year. Okay, so there we go. So PPY is once a year. Okay, which of the following recurrence relations could be used to determine the value of the truck after N years? So this is the column that has the recurrence relation. So this one's the recurrent. So we're looking at this. So you can see here, this is how you write it out. So you write VO, and they've all got the same VO, so that's fine. So really we're just looking for how to do the rule. And the rule part is this R times Vn. So this R is what we've got to work out. So if we go and look at R, and we've got the formula, it says 1 minus the rate, which is 8.5, over how many times a year, which is 1 over 100, and that's how you write. So if you look at that, that will end up being 0.915. Okay, so if we look at that, our formula will just be 0.195 times Vn. So here's how I got A, okay, because I've put that into that formula. All right, so consider the recurrence relation here. This recurrence relation could be used to determine the value of. So what we're going to do is we're going to have a look at things. When you see this bit, so because this number is greater than 1, because greater than 1, it's a growth thing. Yeah, it's growth. Okay, now, but because if you look at this little bit, when you're taking away stuff, you're taking away an amount, well, that's a decaying thing. So what could this be? If you look about it, think about it, a home, if you had a loan or you had a loan, it would grow. So possibilities it could be it's a loan that you're paying off. So there's the payment. So the bank is charging you interest, but you're taking away payments. It could be an annuity. So it's an investment, which is an annuity. So that grows where you're taking payments, where you're taking out payments. And the same, it could be a perpetuity as well, where you're taking payments. Now the payments will equal the interest that you gain if it's a perpetuity. So we're looking for things like this. So let's go have a look. When it's got this minus 2,000, let's see what the percentage is. So I'm talking about this 0.3. So it's growing by, if you think about it, this thing is growing by, I'm going to say 1.3%. So I've just changed this bit to a percentage. It's growing by 1.3% every time, you know, every time the recurrence relation goes. So if I find out what is 1.3% of the VO, which is 125,000. So I'm going to go find that out, because if that matches 2,000, then that would be a perpetuity. But let's have a look at what that. This ends up being 1625. So that means that this investment, or whatever it is growing. It's going up because there's got interest, but what we're taking away is more than what it earns. So at the moment, so it's definitely, I'm going to cross out that it's not a perpetuity. It could be an annuity with withdrawals of 2,000 per quarter. That could be true, because it is growing, because it's got growth, but you're just taking out more. And with an annuity, they go, you slowly zero them out. So, but it says an annuity investment with additional payments. That's not true, because it's not you're not adding 2,000. An item depreciating at a flat rate of 1.3% per quarter per price. It's definitely not that. It's flat rate means the same amount every time. The percentage timing here, when you're timesing, that's a not flat rate. And a compound interest investment, earning interest at a rate. Well, it's not an investment because you're actually taking stuff out of it as well. So this is not the answer either. So that's how I'm coming up with B as my thing. So there's a few things to think about with that. Okay, so with these questions, oh, sorry, not even on there. With these questions, Marty has been depreciating the value of his car each year using flat rate. So flat rate depreciation, we should see a straight line. So when you have the same amount coming out every time, it should be a straight line. And then after 3 years of ownership, the value of the car was halved due to an accident. Marty continued to depreciate the value of his car using the same amount every year. So something happens at the 3 year mark. It drops. It has a big drop in price because it halves. But then it goes back to flat rate, which should be a straight line. So which of the following graphs would represent this? So if you have a look, I'm going to say with this one, it's going down the same cost every time. There should have been a massive drop. So I'm going to get rid of that. Now, if you look in B, this is remaining the same price. It does halve at 3 years, but it's not dropping, and it should be because it's depreciating. So it's not that one. If you look at this one, at C, you can see, yeah, it's dropping at the same rate for that first year. Then if you look at it, here's where it's halved, and then it starts dropping at the same rate. And you can see the steepness of these two are the same. So because the steepness equals same, that means the rate is the same. Equals same rate. Okay, so that one, to me, this one looks like a goer. If I have a look at the other one, this one, it's flat rate at the start, but this looks curved. So this looks curved, so that is not flat rate. And then the same with these guys, they look curved, they're not flat rate, they're not a straight line, so we're getting rid of those two as well. So there's our answer. They love a graph one on your exam, and so they've been doing, I think there's nearly one every year. All right, the value of an annuity investment in dollars after N years can be modeled by this recurrence relation below. So here we go, here's the growth, that's where it's growing. So I can see, I'm gonna write over here, that's growing by, if I change that to a percent, it'd be, oh sorry, it's not even that. It is 0.34%. That's how much it's growing by. And it's also, this bit is also that you're adding extra 500 every time. Okay, So between the second and the third, the increase in value of this investment is closest to. So what second and third years, what I'm going to do is I'd probably look at this on the calculator. So where I'm going to pop it in my 46,000, press enter, and then I'm going to do the rule, and I'm going to look at the third and fourth year. So I'm going to go do here. You can see there's the C. All right, I'll pop in the calculator a bit after. Okay, so Daniel borrows 5,000, which he intends to repay in a lump sum after 1 year. The annual interest rate and compounding period of 5 different compound interest loans are given below. When fully repaid, the loan will cost Daniel the least amount of money. Which one? So this is just pretty much, this is an example of effective interest rate. You want to know effectively which one is the best one. So what you type in your calculator, you write effect EFF, or you can go into menu finance and get it, but it's just pretty much EFF. And you put the per annum rate, which is 12.6, and then you go comma, then you put the PPY, which means how many times a year is it compounded. Now they've said weekly, so if it was weekly, you write 52, and that will tell you your effective interest rate. And the same here, you got 12.8, and they're doing it weekly as well. So if you looked at that, if you've got in a loan, you want the lowest rate, because you don't want to pay the bank too much money. So already between these loan 1 and loan 2, if they're both weekly, you would take the lower interest rate. So I'll get rid of him already. I know that loan 1's better than that, so I'll let that go. Same with this loan 3, it's higher, it's 12.9 compounding weekly, so I'm still going to get loan 1's better than that at the moment, so I'm crossing that one out. The next one I can't really tell because it's saying it's quarterly, so it's not the same scenario and it's a different rate. So I'm going to say 12.7 quarterly, which means 4 times a year, and I'll look at what that effective interest rate is. And the next one, loan 5, is 13.2, but it's also quarterly. So I know for a fact that loan 4 must be better than that, so I'll get rid of that. So I'm down to 2 options, and into my calculator, I'll just put the EFF, write them on. This one was 13.41%, and this was 13.31%. So loan 4 was the better option there. So you can see how I didn't have to do all of them. I could quickly work out that I only had to check 2, and that's something you could do in your reading time, like, because you can't use your calculator, but you could use your common sense there and work out, eliminate a few, and then you only have to check 2 when you go in to do it. Okay, the graph below shows the value of an asset as it depreciates over a 5-month period. Which of the following depreciation situations does this graph best represent? So what we're looking at are the drops. So if you look here, when it goes from here to here, it's dropped down in 1 box, whatever it was, and then it drops down 1 box again. So at the start, this is a straight line, and it's dropped by the same amount. So over the first 2 years, it dropped by the same amount. It then it drops here. So say this drop, it goes 1, 2, 3, 4 boxes. So it's dropped 4 boxes. But then if you look here again, this one's 1, 2, 3, 4, so 4 boxes. So this, and 1, 2, 3, 4. So this is also a straight line with bigger drops. Okay, so it means the straight line means flat rate. So we definitely can get rid of reducing balance depreciation. It's not looking like that. It's a straight line. So it says a flat rate depreciation with a decrease in the depreciation rate. Well, when you get a bigger drop equals bigger depreciation rate, because you're dropping by more. So that first statement is not sounding very good, because it's actually gone increased. So I'm really going to get rid of that one. The flat rate, it does not decrease, it gets increases, it gets bigger. So B, a flat rate depreciation with an increase in depreciation after 2 months. That one I like. That one looks good. I'll just check what it says for the other one. Unit cost depreciation with a decrease in units used per month after 2 months. It's not a decrease in the units used. It's the amount. It's definitely not going to be like that. So I'm happy with this B. It's not, the unit cost decrease, unit doesn't change. Unit cost is always the same cost for every unit. It should have been written differently. All right.